And so let's look at some examples of quadratics. Okay, a couple that we already looked at that meets this, the quadratic. We also have area of a circle. And then one that we'll be using quite a bit of is a formula that represents the height of an object dropped from some height. The height of an object after t seconds when it was dropped from this height. This is the formula we use. This is the original height. This is the height after t seconds. This is the gravity constant, which I will explain now. You have two objects. Ooh, he kind of blends in with the shirt, doesn't he? Let's have this one. Okay, this one. Oh, he blends in with the tie. Got all types of colors going on here today. We have a big object and a small object. When they're both dropped, Galileo demonstrated this. When they're both dropped, they fall. Well, this thing caught in my finger here. Try that again. The teddy bear's dress caught on my finger. I know that sounds kind of bad, but try this again. When you drop them both at the same time, they land at the same time. And that's because gravity is pulling on them at the same force. So it's constant. Take a look here. The gravity is constant unless you have some sort of wind resistance. If you drop a sheet of paper, of course, that's going to float down slowly instead of fall like the bear and the bird did here. So what is this constant? It's 32 feet per second squared. That's acceleration. That means not only do they fall at the same rate, but they're accelerating at the same rate also. So this is a formula that we'll be using quite a bit of now in quadratics. And finally, I had mentioned this earlier. We want to look at the graph of a quadratic, which will be a parabola. And I had shown you that the parabola, the quadratic, is one possible function to model real-life situation like profit. We talked about the number of employees for your X, and then for your Y, you had the profit that you make, or maybe sales or something like that. And so we want to talk about the maximum value, which would be at the very tip top of the parabola. Or you might want to talk about a function that's a u like this, and with a bottom, which would be a minimum. Maybe you want to minimize cost. This could be a cost function, and you want to find where it's the minimal value. And two other very key points that we'll actually focus on in Algebra 1 would be the zeros, and that's where you break even. We'll focus on these in Algebra 1. You start getting into maximum and minimum functions in Algebra 2. So we're going to focus more on the zeros, which we've already done using the x-intercept as a solution. So we've done a little bit of this already. And I said this, or the maximum point, is something you'll do more so in the future. There are different